right, 12.4. Finding sums of infinite geometric series. What does infinite mean?
It's no end.
It does not stop. There is no end. It goes on forever. Okay, correct. Okay. So in infinite geometric series, you can find the sum as it approaches a limit, but R has to be in between -1 and 1. Okay, so what happens is, like, when your ratio is in between -1 and 1, that means it's a what?
It could be 0.
It could be 0. It's a fraction. It's either a negative or positive fraction. Okay? So it's going to approach an answer. That's why we can find a sum. When it's going on forever, it's going to get really, really, really close to an answer. If it's larger than 1 or larger than -1, then that means it's going to keep getting infinitely bigger. But if it's a fraction, if it's smaller, it's going to approach an actual answer. Okay? So, you're fine. So we have here our geometric series. What is the ratio on this one? 2. Okay, it's multiplying by 2, right? So this one I could not find the answer to. Do you see how it's going to keep getting bigger and bigger and bigger and bigger? Okay, so there is no way of finding the answer to this series. But in this one, what's the ratio? Good, the ratio is 1/2. So this one's going to keep getting smaller and smaller and smaller. Okay, and so on this one, we are able to find the answer. Okay, because it's going to approach an answer. Okay, so the sum of an infinite geometric series. So remember, infinite goes on forever. When you guys are writing on your formula cards, make sure that you understand that this one is the sum for an infinite geometric series. Okay, but R has to be in between -1 and 1. If R isn't between -1 and 1, then you would just say, no solution. It's not possible to find the answer to it. Okay, so here's our formula. Find the sum of each infinite geometric series if it exists. So on this one, it goes 8 plus 4 plus 2, and it goes on and on forever.
Divide by 2.
Yeah, the first thing you have to do is find the answer. And if you don't have this from yesterday, remember that your ratio, you can find your ratio by writing your second term divided by your first term. And remember how we showed yesterday that you can really do any of them. You could go 4 divided by 8 or 2 divided by 4, and you just reduce it and you get your ratio. So in this case, if we take 4 divided by 8, that reduces to what?
1/2.
To 1/2. Will that ratio work in order to find the sum?
Yes.
Yes, because it's it's a fraction, right? It's in between -1 and +1. So that means we're just going to use our formula, which is right up here. So we need to know our first term. What is my first term? 8 divided by 1 minus R, and in this case, R is 1/2. Whenever you're subtracting fractions, they need to have what? Common denominators. Okay, so on the bottom here, I want to make this 1 have a denominator of 2. Therefore, the top will also be 2. Because 2 divided by 2 reduces to 1. Okay, so I'm just rewriting this so that it has a common denominator. So now I can subtract the tops.
Okay, here's my question. Sorry to interrupt, but since you only did it to 1, can we don't do it all times?
This one already had the denominator of 2. Okay, so now we just subtract the top numbers, and 2 minus 1 is what? 1. And you keep the same denominator. Okay, that's the whole point of getting common denominators. And then we have 8 on top. And how do I get rid of the fraction on the bottom? You multiply by the reciprocal. So I'm multiplying by 2 over 1 to the bottom so that everything will cancel out. And whatever I do to the bottom, I also have to do to the top.
So it's 8.
So 8 times 2 makes 16. So the sum of this infinite geometric series is 16.
You know what I just realized?
No.
You know how you multiplied your last step on this, you multiplied by 2?
Mm-hmm.
Well, if you had added 2 is in your sum already, put it out there.
Okay, I'm not sure, but it won't always work out that way. Okay, all right, any other questions on this one? It won't always work that way, though.
No.
Okay. All right, can I change this? Yes? Okay. So, example 2, it says, what is the sum of the infinite geometric series that they have right here? Okay. So, the first thing, before you can decide if the sum even exists, the first thing you always have to do is what?
Check.
Check for the ratio. And depending on the ratio will depend on if it exists or not, right?
It's not exist because it's multiplying by 3.
So, we're going to give everyone a chance to try this out. So, first thing, find your ratio. How do you find your ratio? Close. Good. Second divided by your first. So, when you do that for your ratio here, my second term is -3 divided by 1, which makes -3. Does that fit in the parameters for finding the sum? No. Therefore, the answer is does not exist. Yes.
If it's going up, is it always going to be does not exist? And if it's going down, it's always going to be exist?
Yes, I believe so. Yeah. But you know how sometimes you get the fractions like 4/3, and so it'll be a little confusing to tell. So you just always have to check it.
All right.
All right. So Austin, I don't know if you guys heard him, but he said, so basically, if it's increasing like this, normally it's going to not exist. And if it's getting smaller each time, then that's usually when you can find the sum. And that's correct. But you have to be careful because sometimes remember how your ratio is like 4/3 or something, and maybe you can't tell with the fractions what's happening. So make sure you always check, because 4/3, would that work to find the sum? No, because 4/3 is greater than 1, right? Okay. All right, example, yes.
Does it not exist because it's a negative?
No, because this number is not in between -1 and 1. So your ratio to find the sum, if it's infinite, has to be between -1 and 1. Okay? All right. So remember what's really nice about when the sum is written like this is remember your formula. Remember your formula is AN equals A1 times R to the n minus 1. So we don't have to do very much work on some of these. If I look here at my ratio, will my sum exist? Yes, it will, right? Because this sum, see how this is where the n minus 1 is? The n minus 1 is always connected to the R. If there isn't another number there, my first term then has to be what? 1. Okay? All right, so will the sum exist on A?
Yes.
Yes. So my formula, if you need to go back, the sum formula is what?
A1 over 1 minus R.
Perfect. Okay, so that means my sum for this one will be 1 over 1 minus, and my R is -1/2. So 2 negatives make a, in order to add fractions, they also need to have common denominators, right? So what would be my common denominator for this one? 2. So I'm going to rewrite this as 1 over, and then we want a denominator of 2 on both of them. This one already has a 2, so I keep the 1 on top. So this one, in order to make it 1, and for multiplying by 2, we end up getting 2 on top, right? So then we end up with 1 over, and 2 plus 1 is 3 over 2. And how do you get rid of 3 over 2 on the bottom? Which would be to the top and the bottom. And so what does my answer end up being? 2 over 3. So your sum is 2/3. Do I have questions on this one?
Oh, the next one's
Okay, so look at B. What is my ratio?
1 and 1/4.
1 and 1/4, or we could just say 5 over 4, right? So will the sum exist?
No.
S equals 2
Clayton, will the sum exist? On B.
Oh my gosh.
I know. Okay. In order to check if a sum exists, the ratio has to be between -1 and 1. So what is my ratio on B?
5 over 4.
My ratio is 5 over 4. Is 5 over 4 between -1 and 1?
No. Wait. Just told me to.
Yells are. Is 5 over 4 between -1 and 1? No. That's correct. Therefore, if that number, if the ratio is not between -1 and +1, the sum does not exist. Instead of writing sum does not exist, I'm just going to write no solution, 0 with a line through it, can't find the answer. It's much quicker.
Can I try no?
Yes. Yes, you can write no.
Wait, can we just write 0 with a circle through it?
Yes.
Do whatever you want.
But do not write 0 because 0 would be an answer of 0.
With the line through it,
Okay.
not circle.
All right.
Yeah.
Are we good with B? Do we understand why it's no solution?
Yeah.
Yeah.
Okay. Clayton, do you know why it's no solution? No, because you weren't listening when I was talking because I saw you still talking even after I... Can... Okay, are you listening? Can you hear Melanie? Okay, she said the sum does not exist because this ratio is greater than 1. Your ratio has to be a number that's in between -1 and 1. 5 over 4 is really 1 and 1/4, which is bigger than 1. So anytime you have a number that is bigger than 1, the sum doesn't exist.
So what did you use the first formula for? The AN equals A1 plus...
This right here.
Yeah.
I just wrote that because that's kind of showing you how your formula is. So your ratio is always connected to the n minus 1 value. And so I knew this ratio is -1/2. If there isn't a number in front, that means that it's actually 1.
Alright.
Okay? All right. So C, it's not written this way, so I have to find my ratio. How will I find my ratio on C? Good. We take our second term divided by our first term. So for my ratio, I'm going to take 3/4 divided by 3. How do I get rid of this 3 in the denominator? You first put it over 1, and then you
Divide by the reciprocal.
multiply by the reciprocal. Good. So I'm multiplying by 1/3 because when I do that, it cancels the whole denominator out. But whatever I do at the bottom, I also do to the top. Now when I go to the top, what happens?
You multiply?
You get 1/4.
Good. The 3's cancel and you end up with 1/4. So that means that my ratio is 1/4. Clayton, I'm picking on you again. Could I find my sum on this one?
Yes.
Yes. How come? Exactly. It is less than 1. It's in between -1 and 1, right? It's a fraction. It'll work. Yes.
Can you just do 0.75 divided by 3?
Do whatever you want.
Wasn't it easier?
0.75. I don't think it is. I think it's easier to keep it as fractions because things normally reduce. What? Yes. So now we can find the sum because the ratio is in between -1 and 1. So I'm going to give you about 30 seconds. Use your formula. I wrote it right here.
Wait, which one is it?
This is your sum formula of a geometric series if the ratio is between -1 and 1. So now find your answer for C. And you can actually show me on your fingers what the answer is once you find it. Good. Good.
So what's 3 divided by 0.75?
This formula is just like your equation for a geometric series. And I just wrote that down so you could see like this 3 represents the first term. The 5 over 4 represents your R and so forth.
Is this the answer?
A.
No.
Is it this?
Yes.
Oh, close enough.
Yes. Yes.
Oh, okay, okay.
Good.
Get it? Alright, so
What are the
this
answers
is the
for?
formula. So
Show
A
me
is
on your
your first term.
fingers.
Wait, is it this?
Yes.
I already did it.
Yes. Good. No.
1 minus
Don't.
1/4.
Yes.
1/4 because 1 minus r and this equals r. So then I convert mine to decimal, so it'd be 3 over
Okay.
0.75. Because 3 divided by 0.75, which is 4.
So the answer is 4. Okay, if you didn't get 4, let's work through this real quick. So, what is the value of my first term? 3. Divided by 1 minus r, which is 1 minus 1/4. Okay? Now that we have that, we need a common denominator. What's going to be my common denominator? 4 over 4. So I'm going to 3 over, and it's going to be 4 over 4 minus 1/4. Okay? So then that becomes 4 minus 1, which is 3 over 4. And how do we get rid of the fraction on the bottom? Multiply by 4 over 3, so that all cancels, but whatever I do to the bottom, I have to do to the top. I can make this 3 over 1. The 3's cancel, and I'm just left with 4 for my answer. All right, any questions? Okay, writing the repeating decimal as a fraction in lowest terms.
Wait, is that r or something?
You're close. This is actually ends up becoming 1/3. 0.3333 repeating is 1/3. But how
So does that mean
does that happen?
1 over 64?
No. Okay, so remember, like, let's say my decimal was not repeating, okay? So this is kind of like, we're going to do a side note over here. Let's say my decimal is 0.3. Do you guys know how to write that as a fraction?
3 over 10.
Okay, that is correct, 3 over 10. How do you know it's 3 over 10?
Because
Because
it's on
10
it's
makes
three,
the whole.
It's 3, and then it's on the 10th spot.
This is in the 10th spot, so it's 3 over 10. And if you check that in a calculator, let me see this on here. 3 divided by 10, and you get the 0.3. Kind of see that. There we go. Okay, so how it works with repeating, and there's like some other information, but do you see how this was repeating at 6-4? Okay, so that means it starts repeating in the what place?
100.
So you're going to write this as 64 over 100 minus 1. And so we get 64 over 99. And if you could reduce, you would want to, but in this case you can't. And if we go 64 divided by 99,
Why are you subtracting 1 on the bottom?
it's what allows it to repeat. Look at.
So it's 64 over 99.
Yep.
So you don't have to reduce it?
It doesn't reduce. So you do B. Your turn. It is 1/3, but do it this way.
So it's 3 over
So what place does this start repeating at?
3,
The 10th place. So we write 3 over 10 minus 1,
which is 9,
which is 3 over 9, which reduces to 1/3. And if we plug that in there, 1 divided by 3, there it is.
I'll pause.